Alright, if something is moving at constant speed, we know that your forces are going to be balanced. If your forces are balanced, if it's moving at constant speed, you do not have an acceleration because you do not have a net force. All of the forces cancel out, so there's no total force. The force that tells me the direction and the amount the object will actually accelerate at, so that's not one specific force in general, it's actually the sum of them all, so it's the net force that tells me which way it would move and how much it would accelerate. The weight of the object, when I ask you for the weight, I'm asking for the force of gravity. You find the force of gravity by mass times 9.8. And you know the difference between weight and mass because mass is measured in kilograms, whereas weight is a force, so it's measured in newtons. What acceleration means is that you have a changing velocity. So that could be speeding up, that could be slowing down. It also includes turning, so even though it stays at the same speed, changing direction changes velocity. The two ways to find net force. So you could plug in net force is mass times acceleration. That only works if you have A though. You also can find the net force as the total of all the forces. So adding or subtracting, add if they're the same direction, subtract if they go opposite directions. Inertia is an object's ability to resist change, and that depends on the mass of an object. So the more mass, the harder it is to change its motion. The different ways to find acceleration, so you can use F net equals ma, or you could be using your Vf equals Vi plus At, Vf squared, Vi squared plus 2Ad, etc. I'm not going to write them all out. One of those equations also can help you find acceleration, and you'll know to use that based on what it's given. If it gives you initial and final velocity, then you're going to use those equations. When do you use the centripetal acceleration, centripetal force? If it's moving in a circle. If it is not moving in a circle, do not use circular motion equations. Force and centripetal acceleration always point to the center of the circle. And do you need a net force to keep an object in motion? No. Newton's first law says an object in motion stays in motion. If it's at constant velocity, you need no net force. Alright, our free body diagram. So basically you're thinking through, is it balanced or unbalanced? Here it's moving to the right at constant speeds, that means balanced. So as long as it's on Earth, it has a gravity force, and because it doesn't say anything about falling down, it must have a normal force holding it up. And moving to the right, it probably has some applied force, and then if it's not accelerating, it's moving at a constant speed, my friction force must be equal. You also could have just left it like this. That could be moving to the right at a constant speed. As long as you have balance, you would get the point. Airplane goes through the air at constant velocity, so very similar. I still have gravity. This is not necessarily a normal force. You can think about it as like the force of the airplane that's lifting it up, and you could maybe keep it like that, or it probably has some applied force from the engine and then friction or air resistance that would be almost like dragging it back, and that way it would be balanced at a constant velocity. Look, accelerating to the left, so that could just be an applied force to the left and then gravity and normal canceling out up and down. You could leave it like this. You could also have maybe there's some friction, but it definitely needs to be unbalanced and it needs to be bigger to the left. Here, a box is being pushed on both sides, but it accelerates to the left. That means there's a bigger force to the left. So maybe something like this, and then gravity and normal force would cancel out. This one is moving to the left as it slows down as it moves. So if it's moving to the left but slowing down, that means there's a force against it or a net force to the right. This would be unbalanced. And it's probably the friction force making it slow down, and then gravity and normal would balance up and down. And then lastly, I have an object falling. I do want to include air resistance. Falling definitely has a gravity force. There's not a normal force holding it up, but there is some air resistance. I'm going to assume that the air resistance is probably smaller than the gravity force because it doesn't actually tell me if it accelerates or constant velocity. Number 12, so a person pushes a baby mouse which has a mass of 0.2 kilograms from 0 meters per second to 0.2 meters per second. Meters per second tells me these are velocities, so that's the first and the second are initial and final velocity. 2 seconds would be the time, and I want the net force. Well, net force is just mass times acceleration. You have the mass, it's 0.2. Now you need your acceleration. But what I have is VI, VF, and T, so I can just plug in VF equals VI plus AT. Vf is 0.2, Vi is 0, A times 2. 0 plus 0 doesn't mean anything, it just goes away, and then you divide your 2 over, so you get acceleration is 0.1. Now that's not the answer, because what I wanted was the net force, so I'm going to plug in net force is mass 0.2 times acceleration 0.1, and that gives me a net force of 0.02 newtons. Now number 13, we want the radius of motion for an object with a mass of 24, moving with a velocity of 5, and I have 300 newtons. It says newtons, so that means that is definitely a force. In this case, this is a force of something moving in a circle, so that is the centripetal force, which is mv squared over r. That is not on your equation sheet, but is just centripetal acceleration with a mass. And now we're going to plug in, I have 300 equals mass of 24, velocity is 5 squared over r. You put this in your calculator, you get 300 is 600 over r. And now this is where people go just try to divide the 600 over. You can't do that because your r is on the bottom. If your unknown is on the bottom, you want to multiply that up so that now it's not in the bottom anymore. So now I have r times 300 is 600, and you divide the 300 over, and that's going to give me r is 2 meters. Alright, number 14. So I have a 20 Newton physics textbook resting on a table. This is in newtons, so that is the force, and that's the force of the gravity or the weight. So if it weighs 20 newtons, then the force that the table exerts on the textbook, so basically it's asking how much does the table push up on the book? Well, it's at rest, which means balanced, so then my force must be 20 newtons up. 20 up and 20 down would cancel out. Alright, the next one is asking about the force needed to establish equilibrium. Equilibrium means like equal or balanced. So what you have right now is 6 this way and 11 this way. I need an additional force on this side, and to make it 11 so that it's equal on both sides, you would need 5 newtons to the left. For number 18, I already have 35 this way, and I have 8 and 16, which gives me 24 right here. So I need an additional force to the right to make it balanced on this side, and I would need 11 newtons this way because that would give me 35 altogether here, which would balance out with 35 there. 16, I want the acceleration of the crate. So acceleration, you would plug in F net equals ma. So this would become just 8 newtons this way and 2, which gives me a net force of 6, and the mass was given to me, it was 4a. Now I have 6 equals 4a, divide the 4 over, you get acceleration is 1.5. And then I also want to put the direction. So here, the net force was to the left, so my acceleration will be to the left. 19, again finding acceleration, so I want net force, so 30 and 80, that becomes 110. 150 and 100 becomes 250. Now these two are opposite directions, so I'm going to subtract and I get my net force is 140. And now you just plug in net force equals mass times acceleration. You divide and you get your acceleration is 5.6. Yeah, 5.6. And then because my net force was to the right, I had bigger force to the right, my acceleration will be to the right. 17, the force required to make it accelerate at 1.5. So if you have an acceleration, you can find the net force because I have a mass of 10 and acceleration of 1.5. So I want my net force to be 15 to the right. So now let's just think, if I have 3 newtons this way, how big does the force to the right need to be? Well, it has to be 18 newtons because 18 minus 3 would leave me with 15 to the right, which is what I want for my net force. And number 20, the force required to make this one accelerate at 4. So I'm going to plug into my net force. 10 times 4 gives me 40 newtons, and that is to the left. So I have 20 newtons this way, I have 50 newtons this way. So you can think about, okay, 50 and 20, really that's just like 30 to the left. And if I only have 30 to the left and I want 40 to the left, then I need another 10 to the left. Oops. Like that. The next one, we are determining whether it's still or at a constant speed or if it will accelerate. So here, this is not balanced, so that means it will accelerate, and it is unbalanced to the right, so it'll accelerate to the right. B is again unbalanced, so I will have an acceleration. It is a net force down, so it will accelerate down. C is balanced, so that could be still, or it could be at a constant speed. You don't know which one. Technically, constant speed includes being still, because velocity of 0 stays 0. But you wouldn't know if it's moving or not. You just know, like, whatever is happening, it's constant. 12, I want to know the velocity of a 50 kilogram car, that's my mass, with a centripetal force of 20, that's FC, and radius of 25. And I'm going to plug into my centripetal force is mass V squared over R. That's 20 is mass 50. V squared is what I'm looking for over a radius of 25. Now, if you have something on the bottom, you can just multiply that up. So then you get 500 equals 50 V squared. And then you need to divide the 50 over. So you get, I can do this, 10 is V squared. And then that's what the velocity squared is. I want the velocity, so I'm just going to square root. And that's where you get velocity is 3.16 meters per second. And then it also asks you to sketch in the velocity, acceleration, and force vectors. So in this case, because the velocity is going around like this, the velocity would be directed up. Your acceleration and your force always point to the center, so both of these would be to the right. And then velocity and then the center ones, A and F, would always make a right angle, so that double checks. Number 23, I have a 220 kilogram crate pushed horizontally with a force of 800 newtons. That is my applied force. And I gave you the coefficient of friction, and then that was my mass. So I want to draw my picture. I have an applied force of 800. I have a gravity force of mass times 9.8, so that's going to give me 2205. And it's not falling down, so that's also my normal force. Now, I gave you the coefficient of friction. If you know mu, you can plug in and find the force of friction. So force of friction is just mu, which was 0.2, times the normal force, the 2205. So that gives me my force of friction is 441. Now I have enough to put that in my diagram. And what I'm asking for is the acceleration of the crate. In order to find acceleration, you need the net force, because then that's ma. Here, these are going to cancel up and down. I have 800 this way, 441 this way. So my net force is just 800 minus the 441. That gives me a net force of 359. My mass is still 225A, and you divide the 225 over. And that's going to give me an acceleration of like 1.596, or you could just say 1.6. And that would be your answer. Number 24, I have an applied force of 40 newtons to the right. So that is my FA. And I have a mass and an acceleration of 6. And I want to know the friction force and the coefficient. So I've been given the mass, so you can plug in and get your gravity force and normal in this case because it's not falling down. And I gave you mass and acceleration, so you can plug in to your net force to get the net force, because mass times acceleration gives me a net force of 30 newtons. And now you just think through, okay, this would be a net force to the right because it accelerates to the right. If I have a force of 40 to the right, how big is the friction force? If my net force is only 30, well, it would have to be 10, because 40 minus 10 would give me 30. And then I'm not done, because I also asked the coefficient. So coefficient is mu. You have to plug into your equation with mu in it. Your force of friction is just 10, looking for mu. And your normal force was 49. So now you just divide the 49 over, and you should get that your mu is 0.2. Yeah, 0.204. And you could just round it to 0.2. That's fine. You don't have to put 3 decimals. 25, a 1.4 kilogram block slides, it's already moving, across a rough surface such that it slows down with an acceleration of 1.25. That's my A. What is the coefficient of kinetic friction if it's pushed with 1 newton? So that's my applied force. So now you just draw your diagram. I have some applied force of 1 newton. Gravity is just mass times 9.8. So 1.4 times 9.8 gives me 13.72. And it's not falling down, so it must be held up with that same force, the normal force. Now here is where it says that it's slowing down. So if it's slowing down, if it's being pushed but slowing down, that means the friction force must be winning. The friction force must be bigger than the applied force because it's still slowing down. I gave you an acceleration, so you can plug in to find the net force, mass times acceleration, 1.4 times 1.25. That gives me a net force of 1.75. And then the key here is that my friction force is bigger because it's slowing down, so this actually has to be 2.75. And there was also no other way that I could have gotten this force. If my net force is bigger than the applied force, that means the friction must have been bigger. And then last step is it asked me to find the coefficient of kinetic friction, so that means plug into the mu equation. Force of friction we just said was 2.75. I'm looking for mu, and then my normal force is 13.72. Now you're going to divide the 13.72 over, and you should be getting mu is 0.2. 26, I'm finding the missing forces, but I've been given the net force. So if my net force is 0, that means they're balanced, or they all cancel out. So then A had to be 50, and B had to be 200, because 50 and 50, and 200 and 200 cancel. For this one, I want a net force to the left, so that means up and down cancel, so you would have to be 300 newtons. Now I want my net force to be 60 to the left. I have 80 to the left, so that means I must have 20 newtons to the right. And then you can always double check, 80 minus 20, yep, that leaves me with 60, and it's to the left still. 28, when the forces are balanced, what is 0? Well, you know your net force would be 0, and your acceleration would be 0, so that means A. Your speed and your velocity do not have to be 0. They have to be constant, they can't be changing, but it can still have a speed. A spaceship in space fires its engines for 3 seconds to speed up. After 3 seconds, the engines are turned off, and then it does not continue to accelerate. It would need that applied force, the engine force, to accelerate, so that's not going to happen. It does not increase speed and then decrease. It actually doesn't change speed at all. It moves with a constant speed because that would be balanced. There's no forces acting on it. There's no gravity, no air resistance, no friction, no applied force, so it just can continue at the speed that it was going at after those 3 seconds until something makes it stop. 30. A 75 kilogram hockey player is skating across the ice at a speed of 6 meters per second. What is the net force required to stop, meaning the final velocity would be 0, the player in this many seconds? So I want net force. Net force is mass times acceleration. I've got mass at 75. What I do not have is acceleration, but I have VI, VF, and T. So VF equals VI plus AT. VF is 0, VI was 6, looking for A, and time was 0.65. I'm going to subtract the 6 over, and then I need to divide by the 0.65. That's going to give me an acceleration of negative 9.23. And the negative just means it's going against the motion. You'll notice that we don't have the negative signs here because I just want the magnitude of the force. That means I don't care about direction. And that's my acceleration, not my force. So I need to plug in F net is mass 75 times the acceleration 9.23. And then when you multiply this, you should be getting 692. And then the closest answer, or the approximated answer, is 690. Again, the negative sign just means that it's against the motion in the other direction, but I didn't need the direction in this because it said magnitude. Number 31, I have a force of 14 newtons to the left applied to a 2 kilogram buck. So in this case, my applied force was to the left. And 2 kilogram block, you can find your gravity by mass times 9.8, so 2 times 9.8 gives me 19.6. And then the block accelerates at 3 to the left, so I'm going to plug in net force is mass times acceleration. So if I have A, you can plug into F net. Mass of 2, acceleration of 3 gives me a net force of 6 newtons. And because it accelerates to the left, my net force would be to the left. Now, my applied force was 14. If the net force is only 6, that means my friction force must be acting on it. So then you can just subtract and you get that your friction force would be 8 newtons. And that was all it asked, the force of friction. So force of friction would be 8 newtons and it would be directed to the right because it's against the motion. 32, a 500 kilogram car sits on the road, so I can find the force of gravity very easily. It's 500 times 9.8, so that gives me 4,900. And then my normal force is also 4,900. And it requires this many newtons to keep it moving at a constant velocity. That's the applied force it needs. And if it's going at a constant velocity, that means the friction force is exactly equal, because constant velocity means the forces are balanced. And then I want to know the coefficient of friction. That's looking for mu. So force of friction is mu Fn. Force of friction is 1470. Mu is what you're looking for. And then we just said Fn was 4,900. Now you just divide over it, and you should have gotten mu was 0.3. We've got two forces, and we have acceleration, and we're looking for mass. Well, we can use F net equals ma. I just said that the acceleration was 2. You're looking for mass. Now you just need to find the net force. 12 to the left and 2 to the right would give me a net force of 10. And now you just plug in 10 equals m times 2, divide the 2 over, your mass must be 5 kilograms. 34, we have a sled that is accelerating at a rate of 3 meters per second squared. If the net force is quadrupled and the mass is doubled, what is the new acceleration? So I'm looking for how acceleration is going to be affected. So I'm going to take my F equals ma equation, and I'm going to solve for a, which means I need to divide the mass over. So acceleration is my net force divided by my mass. Now, if I have a bigger force, that's going to mean a bigger acceleration. Specifically, quadrupled is 4 times the force. And if I have a bigger mass, that actually means it's going to go a little bit slower, because more mass is heavier, so it'll go slower. In this case, it goes slower because it's dividing by the mass. So it's like times 4 on top, but you're dividing by 2 because you have a 2 on the bottom. So I'm going to take my old acceleration of 3, I'm going to multiply by 4, but I'm going to divide it by 2. So I get 12 divided by 2, which is going to give me 6 meters per second squared. Because I did something that would increase the acceleration, more force goes faster, and I did something that's going to decrease the acceleration, heavier will go slower. In this case, it was quadrupling times 4, but then I also doubled it, which is like dividing by the 2, so that would give me my 6 now. Suppose that a sled is being pushed with a constant force. If the mass is halved, what will happen to the acceleration if the force stays the same? So if I have a mass, I pull it with some force m, I've got an acceleration, but now it is much smaller, and I pull with the same force, so I'm going to have a bigger acceleration. Specifically, if it's half, that's a factor of 2, so I'm going to have 2 times the acceleration. And 36, so a person records the following information about a 3 kilogram toy boat, that's my mass. I want the net force from 0 to 2 seconds, so net force is mass times acceleration, you know mass is 3. Now I just need to know my acceleration from 0 to 2 seconds. So what we've been given is velocities in time. My initial velocity at the beginning is 2, and then after the 2 seconds, that final velocity goes to 6. And from 0 to 2, 2 seconds has passed, and I want to find the acceleration using this information. So I can plug into my VF equals VI plus AT. Final velocity is 6, initial velocity was 2, A is what I'm looking for, and time was 2. In order to solve this, I cannot combine these because they are not like terms. So I have this 2 here, I'm going to subtract it over. Minus 2, that gives me 4 is A times 2. Now I can divide the 2 over, and that's going to give me acceleration is 2. And then I'm not done because I actually wanted the net force, but net force is mass times acceleration. Mass is 3, acceleration is 2, so my net force is going to be 6 newtons. And the net force from 2 to 6. So let's look from 2 to 6. My initial velocity was 6, and then it's still 6. So this was at a constant velocity because the velocity was not changing. So my net force would be 0. And you can still plug in if you do the VF equals VI plus AT for 4 seconds. You get 0 is A times 4, so acceleration is 0, which gives me net force is 0. Or you could just think through, oh, it's staying at a constant velocity, that's balanced, net force is 0. 37, I have force right here, and I have acceleration. I'm looking for mass. Well, F equals ma. So I'm just going to pick a point. I think this is like a good point where my force is 0.75. And I don't know my mass is what I'm looking for, but my acceleration was 3. And now you can just divide over, you get your mass is 0.25 kilograms. And you can use any point. You could use this point, this point, this point, any one of them. If you just plug in that force and that acceleration and divide over, you get that for the same mass. 38, I have a net force F acting on a mass M, causing it to accelerate at 4. If I have the same force, but now it's on twice the mass, so think about M force, my acceleration is 4. If I have twice the mass, but I still pull it the same, it's going to have less acceleration. Because this was twice the mass, it's going to have half the acceleration. So if it was acceleration of 4, half that would now be 2. And the reason why this is dividing by 2, even though I multiply the mass, is because we rearranged our equation for A as force over mass. So if I put a factor of 2 here, see how that's 1/2ing the acceleration? So half of 4 is 2. 39, the force of air resistance on a 0.5 kilogram object falling vertically with an acceleration of 8.5 meters per second squared. So I have, of course, the force of gravity, because it's falling. And the force of gravity is just mass times 9.8. So 0.5 times 9.8 is going to give me 4.9. Yeah, 4.9. And then it says that it's falling with this acceleration. So if I have the acceleration, I can find my net force. So plug in, mass is 0.5, acceleration is 8.5, so that gives me a net force of 4.25. Now that's my net force. I'm asking what the force of air resistance is. You know air resistance goes against motion, so if it's falling down, the air resistance would be up. And it's still falling down and accelerating down, so my gravity force is definitely bigger. What I want to know is how big that force up is. Well, let's think. Gravity would be 4.9 down. If your net force is 4.25, then that means that the up force is just the difference of these, 0.65. And then you can double check 4.9 minus the 0.6. Yes, that gives me a net force of 4.25, and it would still accelerate down. 40, I've got a 3 kilogram object being accelerated vertically at this acceleration. So I want to know the upward force in the core. So let's think about 3 kilograms would have a force of gravity of 3 times 9.8, which is 29.4. And it's accelerating upwards, that means I have a net force up. I have the accelerations, you can plug in and find the net force. It's 3 times 2.8, which gives me a net force of 8.4, and that's directed upwards because it's accelerating up. So if the net force is up, that means the force up must be bigger. So the force up is just this one plus the 8.4, and that's going to give me the 37.8, which was D. 41, we have a mass and we have a 120 meter radius, and I have a coefficient of friction, 0.15, and I want to find the force of friction. So force of friction is pretty easy. That is the nu Fn. That means I need to find the normal force. Normal force will just be the same as my gravity if it's not falling down, which a truck driving is not falling down. So I'm going to do mass times 9.8. That's where I get the 24,500, and that's also my normal force. And then it has some friction force because I gave you a coefficient of friction is 0.15 and normal force is 24,500. So that gives me a friction force of 367 newtons. And B is asking what the maximum speed the truck could have made this turn. So if I'm talking about making a turn that's going in a circle, because I talk about radius, and I'm relating that to friction. So this is the case we talked about in class where my centripetal force is my friction force. So when we have an object that is on a surface, in this case the truck is on the road, and it is moving in a circle, my centripetal force is my friction force. So I can say, okay, centripetal force is just mv squared over r, while my friction force is my centripetal, so you can just plug this in. 3,675 is my mass, 25,000, v squared, which is what I'm looking for, over radius of 120. Now I have 120 on the bottom, so I'm going to multiply the 120 up. And that's going to get me a really big number. 2,500 v squared. Now I can divide the 2,500 over. That's going to give me 176.4. That's the velocity squared. I want just the velocity, so I'm going to square root. I get my velocity is 13.28 meters per second. So that is the safest velocity, or the maximum velocity you can safely make this turn. Because if you go any faster, then that would be greater than your friction force, and we want our friction force to be equal to the centripetal force so it doesn't go sliding. And 42, I have a mass, it's traveling some velocity around this radius. I want to find the centripetal acceleration. That's easy, it's v squared over r. My velocity was 25 and radius was 200. So that gives me a centripetal acceleration of 3.125. Centripetal force is, you could just say times mass, or some of you like to just re-plug into the equation, mv squared over mass, or over radius, sorry. And then you have 1,400, 25 squared over 200. That's going to give me a centripetal force of 4,375, which is the same as if I just took this acceleration and multiplied by the 1,400 kilograms. And then C is asking what the coefficient of static friction would have to be between the tires and the cars to make this turn safely. So this is again an object turning in a circle on a surface. So my centripetal force is my friction force. So I can plug in friction is mu Fn. I'm looking for the mu, and I need my normal force. So let's draw a diagram. Force of gravity would be the mass times 9.8, which gives me 13,720. And that would also be my normal, because it's not falling down, 13,720. And I have my friction force, which is my centripetal force, the 4,375. And now you just plug in. My centripetal is my friction force, so I can plug that in for FF. Mu is what I'm looking for, and then normal we had just calculated, so that gives me a coefficient of 0.32. And last one, I have a mass of 1,400, and I have a radius of 9d5. And I have a coefficient of 0.55, and I want to know the maximum speed it can travel at. So let's think, I have m and r, and I have mu. So if you have mu, you can find the force of friction, because it's mu Fn. My normal force is just my gravity force, because it's not falling down. So mass times 9.8, we just said, would be the 13,720. And then that would also be my normal force. And now I'm just plugging in. I gave you coefficient 0.55. Normal we just found. That gives me a friction force of 7,546 newtons. So that's my friction force. And I need to relate that to speed. Well, it's going around a circle, and I'm relating the speed to the force of friction. So this is one of those cases where your centripetal force is your friction force. So I can say centripetal force is mv squared over r. My centripetal force is my friction, so 7,546 equals the mass, 1,400, v squared, what I'm looking for is velocity, over a radius of 95. And now it's just algebra. To get the move the 95, you want to multiply by it. And then you want to divide the 1,400 over. So that's going to give me v squared is 512.05, and that's what velocity squared is. The last step is to square root, and you get velocity is 22.63 meters per second. So key in the last three ones was because it was an object moving in a circle on a surface, your centripetal force was your friction force. And you knew that you had to do something because I asked you to find like the force of friction, and then I related that to speed. So that is how you could tell, like, oh, my centripetal is my friction here.